Hey everyone, welcome back. So today we're solving the problem binary search. So we are given an array of integer nums which is sorted in ascending order. We are also given a target integer which we are going to look for. If the target exists, then we return its index. Otherwise, we return -1. The goal is to write an efficient algorithm that will run in log n time complexity. Now, which algorithm can we use to achieve this? The problem pretty much tells you which algorithm we're going to use, which is binary search. Binary search is a basic algorithm, and a lot of interview problems extend the idea to have more complex questions. Now the explanation. Given the input array is sorted in ascending order, the target value that we are looking for could exist within anywhere in the range of this given array, or it may not exist at all. Now, when we start our algorithm, we will consider the entire array from here to here. How? We are going to use the two-pointer approach. One pointer will be initialized at the leftmost index. The other pointer will be at the rightmost index of this entire array. In this way, we will be considering the entire range of the array from the left to the right. Now, if we would like to only look at one value in our input array and compare it to our target, which value could we decide to choose? For instance, if we decide to pick this first value, we can compare it to our target, and it is clear that this value is not equal to our target. But by doing this approach, we will only have eliminated one possibility, and we will be remaining with this remaining part of the array to look at. Similarly, if we were to look at the rightmost value first, we will only have eliminated one value and will remain with this range for our search space. However, what if we look at the midway point? We can get the midway point by taking the difference between the right and the left value and dividing it by 2, which will land us somewhere in between these two values. Arbitrarily, let's assume our midway point will be at this position with the value 3. What we can ask is this value equal to our target value? Is this value equal to 9? Well, no. However, we can also ask, is this value smaller or greater than the value that we are looking for, the target 9? In this case, it is smaller than our target. What does that tell us? If this value is smaller than our target, then we don't have to consider it anymore. Additionally, it also tells us that everything to the left of this value is also smaller than the target value. Remember that this array is sorted in ascending order, and therefore every value to the left of this that we're looking at number 3 is also going to be smaller than 9, and it is clear that going to the left, all these values are smaller than 9. Therefore, we can eliminate all values to the left because we will never again try to check for our target in that given section. We can represent this in code by shifting our left pointer from its initial point to m+1. So this will be our new position left, and you can see it's position m+1. So this is where our left value will be. We can cross this out, and our midpoint now will be computed again afresh. So we'll just take the right pointer and the left pointer, divide them by 2, and this will be our new midpoint. And now, from this point, we just need to repeat what we've been doing with the algorithm again. We check the value 9. Is it equal to the target value? In this case, yes, it is equal to 9. Therefore, we can return whatever value m represents in the current position of this array. And by that, we have eliminated all the other values. We are not going to check them because we have found the solution, and that is represented by m. With that said, let's code up the solution. So like we discussed in the drawing, we'll have two pointers, the left and the right. The left pointer will be initialized to 0, and the right pointer will be initialized to the end of the array. Our algorithm will run while the left pointer is less than or equal to our right pointer. We will stop whenever these two pointers have already intersected and are not in the correct position. Now, our task is to initialize the midway point, and like we discussed, we can take the left pointer, subtract it from the right, and divide by 2. Now, this will represent the actual midway position, but we want to see this midway position from the left index, so we will add left to this value, and that will represent the midway point in this entire array. The first condition that we will check is whether the value at the midway point is equal to our target. If that's the case, then we have found the value that we are looking for, and we can immediately return position m which represents the index of this value. The second condition that we will be looking at is whether the value at the midway point is less than the given target value. This must mean that all the values to the left of the midway point are less than this given target, and so we must shift our left pointer to the midway point plus 1 as we discussed in the drawing. The final condition that we will have will mean that the first two conditions have not passed, so this must mean that the value that is at position M must be greater than the target. If that's the case, what we will do is shrink the right side of the array to be equal to the midway point minus 1. If we end up ever breaking out of this while loop, that must mean that there is no value we found and we are instructed to return -1 as our default case. With that said, let's see if the code solution works. And as you can see, it's pretty efficient. If you enjoyed this, please like the video and subscribe for more content just like this. I'll see you in the next one.